Why do we test? Well, we all make mistakes. We need to find the defects and fix them. Testing also ensures that software is consistent in look and feel. If you don't test, you go out of business. Good design. The product should do what the customer actually wants in a user-friendly way. It should look attractive. The text and buttons should be sensibly laid out. It needs to work. It needs to do the job, which may be what's in the specification. It needs to work every time, without fail. It hardly ever blows up, is not acceptable. The product needs to be consistent with other previous products. It should have the same look and feel of the other products. It needs to be rugged and able to keep going year in, year out. It doesn't end with the sale. To keep the customer happy, you need to offer a maintenance program. The price should reflect what it's worth, not necessarily what it costs to produce. There are even occasions when it pays to make a loss in order to preserve reputation. Some definitions. An error. This is a mistake made by the programmer. Typos, miscalculations, and misinterpretations. An example, the specification says control the console to 180C. So, the inexperienced code monkey writes software to do it, rather than realizing that it should read 18 degrees C. A defect. This is a bug introduced by the programmer that, while allowing the software to integrate, prevents the proper functioning of the system. So the wheel fits, just won't go round. A failure. This is when a defect runs. It may occur in combination with other factors, such as temperature or the outside air humidity. Or it could sit around like a time bomb and materialize months or even years after installation. The failures need to be categorized. The severity defines how bad the problem is. The priority defines what order we repair them in. In 1946, Grace Hopper joined the Harvard faculty at the Computation Laboratory. She traced an error in the Mark II computer to a moth trapped in a relay, hence coining the term bug. In 2002, a study commissioned by the U.S. Department of Commerce's National Institute of Standards and Technology concluded that software bugs or errors are so prevalent and so detrimental they cost the U.S. economy an estimated $59 billion annually. When you're developing programs, don't be tempted to write the whole thing and then test it. There will be so many bugs, it'll be overwhelming. Instead, write the program in small, bite-sized chunks and check it as you go. Then you know the latest bugs, are probably in the new bit or how the new bit interacts with the previous bit. If you're testing a program for someone else, you should fill in a defect report for each bug as you find it. One of the earliest steps in software testing should be to run it past the customer, just to make sure it's what he wants. There are different testing methods. One is analysis. Analysis, you check the risks and you do a risk analysis and you concentrate on testing possible sources of risk. Model-based. You create a mathematical model and check if the outcomes match. Methodical. Lots and lots of checklists. You create the checklists based on experience or industry models like ISO 9126. Standard compliant. Does it comply to the standards? Use templates such as IEE 829. Dynamic. You check known or suspected weaknesses. Typically you do this near completion of the project. Consultative. We ask the customer what he thinks we should check, and we may even ask him to check it. Customer testing is called alpha or beta testing. Regression-averse. We construct an automatic test system and we test it to death. Unit testing. A unit is the smallest component. In our case, that's usually the individual PLC. You test it to see if the code works. Integration testing involves building the entire system and checking it. Most control systems involve more than one PLC networked together and probably a SCADA on top of that. Big bang testing. You wire it all together, install the software, stand back, cross your fingers, switch it on and hope for the best. It's very fast, but if there are any faults, it's very difficult to isolate the fault. There's also the possibility of disaster. Integration testing, it can either be top-down testing, which starts at the top, usually the SCADA, and works its way down into the units. More sensibly, we do bottom-up testing. We test the units, then we test the units in integration, connected together, and then we finally test the SCADA. System testing is where we check to see if it matches the specifications. Acceptance testing is where we see if the customer likes it. Now we consider some of the so-called non-functional testings, such as reliability. How often does it fail? Usability. Is it easy for the customer to use? Efficiency. Is the program over long and inefficient? Maintainability. Is it easy to maintain? Portability. Is the software easy to move to another platform? Baseline. Does it meet the specifications? Compliance. Does it comply to the IT standards? Documentation. Is the documentation up to date? Endurance. Does it continue to function over a long time? Load testing. This is where we see if it continues to function under heavy load. Does it respond fast enough? Is it compatible with the hardware and the customer? Can it be hacked? Can it be scaled up to a larger system? Can it deal with specific volumes of data? Stress testing is when we test it beyond the normal operating conditions. Recovery testing is we test how it recovers after a crash or after a power failure or on initial startup. That's a cold start. Internationalization is when we test to see if it will work in other countries. What I recommend is a combination of the methods above. I prefer signature sheets to check sheets because they're harder to forge. You check it performs according to the spec. Check it does all the right things in a fire or after an emergency stop and time schedule events. Check it complies with standards. Check the outputs respond correctly to the inputs. Then check the timers, counters, and values such as set points are correct after events like cold starts and warm starts. That's it for testing.